Let's call this example 2. Example 2. So here we are asked to estimate the volume of earthwork required in bank measure for the basement shown above. Values shown at each corners are depth of excavation, while all values are given in feet and also in meters. So these ones are in feet. You can see feet. So at the corner point, these are the depth of excavation. Then for us to do this, because under this example we are trying to illustrate how to estimate the volume of earthwork. So that is what we are looking at. So, and to do this, we use the formula where we say volume. For us to get the volume of earthwork is equal to horizontal area multiplied by the average depth. So that is the formula we're going to be using. So here we are asked to estimate the volume of earthwork required in bank measure for the basement shown above. So to be able to do this, we have the area and we have the horizontal area here. We are given the length and the breadth of this basement area of the whole basement. We will multiply length by breadth. So we are going to have, in feet, we are given 30 and 30 by 25 feet. In meters, we are given 9.15 by 97.63. So for our area, what we need to do is, our area is equal to, in feet, it's going to be 30 by 25, and this will be equal to 750 square feet. Then also in meters, what we are going to do is we are going to multiply 9.15 multiply by 7.63. So if we do that, we'll have a total area of 69.8 meter square. So that's what we have. So we've been able to get our area. So our average depth is the next thing we need to get, both in feet and also in meters. So to get the average depth, we add this in feet, these corner points, and we divide by 4 because there are 4 points there. So what do we need to do? Our average depth will be equal to, we add 6.0 plus 5.6 plus 7.6 plus 6.2. This we divide by 4. When we divide this by 4, it will give us a total of 6.9 in feet. We also do that in meters. Our average depth in meters, corner points, this will be equal to 1.8. We have 1.8 plus 1.8. This is 1.8 plus 1.8 in meters. So I have 5.6. We have, okay, we have 1.8 plus 1.8 plus 1.8 plus 2.3 plus 2.5. We will still divide this by 4 because we have 4 points. That is this plus this plus this plus this divided by 4 because I have 4 points. So this will be equal to, punch that with our calculator, we'll get average depth of 2.1 meters. So here from our formula, our volume is equal to horizontal area multiplied by average depth. So let us get our total volume. So our horizontal area in feet, we got that in feet and we got that in meters. So volume in feet will be equal to the horizontal area we got today. We got 750 and the average depth we got is 6.9. So that is what we have. We will divide this by 27 because we are multiplying. We want to get the values or their answers in feet. So this will be equal to 191.7 BCY, bank per cubic yard. So for us to get that in meters, we are going to multiply the meter. We've gotten that in feet. In meters, we have this already, 69.8. This will be equal to, we've gotten our, here we have, we said average horizontal area, and our horizontal area here is 69.8 multiplied by the average depth. Our average depth here is 2.1 meters. We don't need to divide by 27 this time. We'll have a total of 146.6 BCM. So this is our volume in meters, in bank per cubic meters.
Sounds of Neptune.
So for our trench excavation, let's take another example. Find the volume in bank measure of excavation required for a trench. That trench is 3 feet or 0.92 meter wide, or 6 feet, which is also equivalent of 1.83 meter deep, and 500 feet, which is 152 meter long, assuming the trench sides will be approximately vertical. So in this case, we have a trench, given a trench. Our trench in the length is 500 feet. The equivalent is 152 meters. The thickness or the width of that trench is 3 feet or 0.92 meters. So here we are asked to get the volume. Remember we said volume is equal to horizontal area multiplied by average depth. So what is our horizontal area in feet? The area is length times breadth, where this will be equal to the length, which is 500, multiplied by 3 in feet, and we should also remember that we are given a depth of 6 feet. So the depth of this, the depth is 6 feet. So let us also put this down. Depth is equal to 6 feet, which is equivalent of 1.8. Given 6 feet, which is 1.83 meters. So here we have this. We multiply this by this. This will give us our this. So we have to multiply by this is our average. This is our horizontal area. Beg your pardon. So we divide it by 27, or let's just get the area first, and then when we multiply this, we are supposed to, the average depth is 6, so we can express the same thing at the same time because we're talking about horizontal area. So since we are multiplying in, we want to get in cubic or in feet, so we divide by 27 and we say 500 by 3. This 500 is the length, the width is 3, and the average depth is given to us, only one depth is given to us, so we use it, which is 6. So I have 500 by 3 by 6 over 27. So this will be equal to 500 multiplied by 18 over 27, and this will be equal to 333 bank per cubic yard. So for us to do that in meters, we can also do that in meters. In meters, we are given 152 meters as the length, multiplied by 0.92 as the width. Then the average depth is 6 feet, which in meters is 1.83. 1.83. We don't need to divide by 27 because we are expressing in bank per cubic meter. So our answer will be, we will multiply this by 152. What we will have is, we're expected to have 255 BCM bank per cubic meter. So that's what we have from this calculation. So next we take a look at for large areas. We want to get for large areas. The difference between this one and for large areas will be, we'll still use the same formula, which is the volume. Here we said the volume is equal to horizontal area multiplied by the average depth. So the difference between this and the previous example is that we have several depths at different points, different corner points. So what we're going to do in this case is, we are going to get the area of the whole shape. We are given an area, or the excavation. Here we said find the volume of excavation required for the area shown in the figure. Then the figure at each grid intersection represent the depth of cut at that location. The depth is in parentheses. The depth in parentheses represents meter, while no parenthetic figure stands for feet. So what we're trying to say here is that these very ones are in feet. These are depths, these points. So we have the corner points. These are the corner points. And the remaining these and these make up corner points. These are the border points. This very one, this are the border points. Then these ones are the interior points. We call this the interior points. That is this, and this. So let's clear it in order to have a clean working area, or to understand what we're doing in order not to confuse ourselves. So what we have to do is, okay, so now what we have to do here is to solve this solution. Take for the average depth, because that is what we are looking for. The area is very simple. The area, or the horizontal area, is equal to 400 in feet multiplied by 300 in feet, and this is the same thing as 1002 or 120,000 square feet. In meters, we will use the equivalent, which is, in meters we are given 121.9 multiplied by 91.4. So what we'll have here is, in meters is going to be equal to In meters, we have, if we punch that, we have 11142 meters square. That's the area in meters. So what we now have to get is the average depth. So we take the, first of all, for the average depth, we have to consider the corner points. The corner points in feet. For us to express that in feet, these. There are 4 corner points. 4 corner points. And we have how many border points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 plus 10 border points. Then interior points, we have 1, 2, 3, 4, 5, 6. We have plus 6 interior points. Okay, so for the corner points, we have to consider 6, which is this plus this plus this plus this. So we have 6 plus 4 plus, what we have here is 2 plus 3.4. We have this. Then we will have, if we add all of them, we have 15.4 feet. Then if we're expressing this in meters, it's going to be 1.8 plus 1.22 plus 0.61 plus 1.04. So let's do that. 1.83 plus 1.22 plus this 0.61 plus this, which is 1.004. So if we add this in meters, we're supposed to have this will be equal to, because this is 4, so we have this as 4.70 in meters. So these are the corner points. For the border points, we do the same thing. For the border point, we have, the border points are these. I've said that earlier. We have about 10 points. So we have 5.5 plus 4.8 plus 4.8 plus 3.5 plus 3.0 plus, we have here 2.8 plus, next one is 3.0 plus, next one here is 4.6 plus 5.2 plus the last one, which is 5.2 and 5.6. So when we add all this, for the border points, we are supposed to have 43 feet. So we can still do the same thing for the meter equivalent. For the meter equivalent, we have 1.68. For the meter equivalent, we have 1.68 plus 1.46 plus, we have 1.46 plus, here we have 1.07 plus, here we have 0.92 plus, here we have 0.85 plus 0.85 plus, we have 0.92 plus we have 1.40 plus we have 1.59 plus we have the last one, which is 1.77. so this will give us a total of to be equal to in meters. We'll have 13.12 meters. So that's the value in meters. So let's wipe the top so that we can be able to have free working space. Let's wipe the top. Okay. So here we have so here what we do next is we now look at the interior points. The interior point, I said earlier, there are 6 interior points. So if we're doing that in feet, for the interior points, this will be equal to, for the interior point, we have the first one, which is 5, plus we have 4.6, plus we have 4.2, okay, plus we have 4.9, plus we have 4.0, plus we have 3.6. So when we sum all this for the interior points, we will have, we sum all this for the interior points, mind you, set 5.0 plus 4.6 plus 4.2 plus 4.9 plus 4.0 plus 3.6. This will give us a total of 26.3 feet. So if we express that in meters, this will be equal to, in meters we have the equivalent here, 1.52 plus 1.40 plus 1.28, yeah, plus we have the next one, which is 1.49 plus the next one, which is 1 point, beg your pardon, this is 1.22 plus 1.10. So if we add these 6 interior points, we are going to have this to be equal to 8.01 in meters. Okay, so we've been able to get all our points. Then for us to get our average depth, remember we said our volume is equal to horizontal area multiplied by average depth. So for us to get our average depth, so for us to get our average depth, we need to add, here we have our average depth will be equal to, for the corner point we are going to multiply by 1 because we have only one square here. For the border point we have 2 squares, like this point is bordered by 2 squares. The interior points are bordered by 4 squares. So we're going to multiply our total corner point in feet is equal to 15.4 feet. So we will multiply by 1, which is still 15.4, plus our border point, the total in feet is 43. So we're going to multiply by 2 times 43. Like I said earlier, these are border points bordered by 2 squares. So plus The other one, which is the interior one, aborted by 4 square. This is an interior point. So we're going to have 4 multiplied by our interior point. We got how many in feet? We had 26.3 feet. Okay, so when we add this 4 times 26.3, we don't need to write feet, so we have 4 times 26.3. So here, this will give us, if we do that, how many total points, because we are taking average depth. We're doing this, how many points? Remember I said we have 4 corner points, 10 border points, and 6 interior points. So when we add all of them, we are going to have 48. How are we going to get that? This is 1, 2, 3. We count this twice, we count this 4, or we can easily say, since we said earlier that we have 4 corner points, so we still 4 plus, so we want to get our average, plus we have 10 border points, so it's going to be 10 for each border point. Remember, we are multiplying by 2, so it's going to be 10 times 2 plus the interior points are 6, 1, 2, 3, 4, 5, 6. So 6, and they are bordered by 4 squares times 4, which is 24. So we have, this will be equal to 4 plus 20. 10 times 2 is 20 plus 24. So this will give us a total of 48. So we are going to divide this by 48. So this will be equal to, when we divide all this, we're going to have an average depth of 3.97 in feet. So we can also express that in meters. For us to express that in meters, let's wipe the earlier calculation so that we can have space to do that. Okay. Okay. So here we have
the best of magic. Sounds of Neptune.
Okay, so let's write that in meters. So in meters, our average depth will be equal to the values we got in meters. For our corner points, remember we had in meters 13. For the corner point we had 4.7, so it's going to remain 4.70. We are not going to multiply by anything because it's still by 1, only 1 point, 1 sector here, or 1 square here. So plus for the border point, we multiply by 2, so we say 2 times our border point in meters is 13 point in meters. We had 13.12. This is 1, so 13.12. Then plus the interior point in meters, we got 8.01, so we're going to say 4 times 8.01. So we're going to divide by the average depth, but the earlier average depth is 48, so this one is still 48. So what we're going to have is, we will have a total of, if we do this calculation, we'll have this as with our calculator, we're expected to have an average depth of 1.21. So we've gotten average depth in feet and also in meters, and we've gotten the area both in feet and in meters. So we got this as the area in square feet and this in meters. So for us to now get our volume of excavation in bank per cubic meter and in bank per cubic feet, the next thing we now need to do is we look at, we said our volume is equal to average area times horizontal area times the average depth. So our volume this time is going to be equal to in bank per cubic feet or cubic yard. I beg your pardon. So what we're going to have here is our area we got earlier is 1,000 or 120,000 square feet, multiply, because this is our area, horizontal area, multiplied by the average depth, which is 3.97. So we'll divide this by 27 in order to get our answer in bank per cubic yard. So this will be equal to 17644 bank per cubic yard. So to get the answer, the volume also in meters, so we'll do that in meters. This will be equal to, our volume is 11142. We're going to have 11142 multiplied by our average depth is 1.1 to 1.21. 1.21. We're not going to divide by 27 because we are getting it in bank per cubic meter. So this will be equal to 13482 bank per cubic meter. So that is what we have. So this is our volume in bank per cubic yard and volume in bank per cubic meters. So viewers, this is where we'll come to the end of today's lecture on how to estimate the volume of earthwork. Please, if you're yet to subscribe, please hit the subscribe button. Hit the subscribe button, and then you will also see the notification icon or the bell icon. Click the bell icon in order to receive updates on our new videos. Then if you love this video, you can also give us thumbs up. Give us a thumbs up. So thanks for being part of this video. My name is Engineer Obonna Nnamdi. See you in the next video. Bye for now.
It's visible.